Students, welcome to your chemistry class. Let us further discuss the chapter chemical bonding. The topics that we have already discussed are introduction to chemical bonding and types of bond. In today's class, we are going to discuss electrovalent bond, and in that we will be studying its define, conditions for its formation and examples of electrovalent compounds. To understand electrovalent bond, let us first take the example of formation of sodium chloride. For forming sodium chloride, first of all, we should know that what is its atomic number and what is its electronic configuration. Atomic number of sodium is 11, and as you know, its electronic configuration is 2, 8, 1. So it has one electron in its outermost shell. If sodium will lose that one electron, it will acquire nearest noble gas configuration. So therefore, what sodium does is, sodium will lose that electron and form Na positive. And that electron which sodium has lost, it will be gained by chlorine, because the electronic configuration of chlorine is 2, 8, 7. That means it requires one electron to complete its octet. So therefore, chlorine willingly gain that electron and form Cl negative. And as this is losing and gaining of electron is going on, in that case, the bond that is formed is known as electrovalent bond. The charge is positive on sodium and negative on chlorine. Oppositely charged particles are attracted towards itself, and the bond formed by such an attraction is known as electrovalent bond, and the attraction is known as electrostatic force of attraction. So let us discuss and define now electrovalent bond. Electrovalent bond is a bond formed by transfer of electron between a metal and a non-metal. Because metals are the substances that will give the electron, they will lose the electron, and non-metals will gain the electron. Similarly, the compounds that are formed, they are known as electrovalent compound. The other name of electrovalent compound is ionic compounds, and electrovalent bond is ionic bond. So the other name can also be there in the exams and books. Okay, so don't get confused. Electrovalent compound is a compound formed by transfer of electron between a metal and a non-metal. Examples of electrovalent compounds are sodium chloride, magnesium chloride, calcium oxide, sodium oxide. We can take many more examples like potassium chloride, potassium oxide, lithium oxide likewise. Why? Because in this compounds, what happened? There is a transfer of electron. If a compound has a metal and a non-metal, the bond that exists between them is an ionic bond. So remember that as well. The next is, we need to study conditions for the formation of ionic or electrovalent bond. We are having a neutral atom. Take the example of sodium. Supposing when we take example of sodium, sodium will lose electron and form a cation. If we have chlorine, chlorine as it is a non-metal, it will gain electron and form anion. Positively charged ions are known as cations, and negatively charged ions are known as anions. The formation of cation and anion depends on some following factors. What are those factors? The first one is low ionization energy. That means if the ionization potential or ionization energy of a particular atom is low, it will lose electron easily. That is, a cation is formed easily. The second is high electron affinity. If the electron affinity value is high, an ion will be formed easily. That is, a higher electron affinity value favors the ionic bond. Electron affinity is electron gaining capacity. Yes, energy released when electron is gained by a neutral gaseous atom. Ionization energy is the energy required to lose the electron. So lower the energy required, more easily the electron will be lost. And the third one is large electronegativity difference. If the difference in the electronegativities of two elements is higher, then the transfer of electron will be easier. Therefore, more the difference in electronegativity, more will be the ionic nature of the resulting compound. We know what is electronegativity already. The tendency of an atom to attract shared pair of electron towards itself. Okay students, so these are the three factors on which ionic bond formation takes place, that is low ionization energy, high electron affinity and large electronegativity difference. Now initially we have discussed some examples. We have discussed only examples of ionic compounds. Now we will be seeing that how we need to draw the structures of ionic compounds. If we are about to show the formation of sodium chloride, how we are going to show its formation. There are two types of diagram. The first one that we are doing is electron dot diagram. Second is orbital diagram. In electron dot diagram, remember that we will be considering only the last shell of electron, that is the outermost shell or valence shell. So one by one, let us discuss that how we are going to draw electron dot diagram of ionic compound. The first one is sodium chloride. Sodium atomic number 11, chlorine atomic number 17. Down to it, you will be write its electronic configuration. 281 for sodium and 2,8,7 for chlorine. Then for electron dot diagram, as you know, you will be considering valence electron. So sodium, you will be drawing its valence electron. You can show it with a cross or you can show it with a dot. If one you are showing with the cross, other one you will be showing with the dot. Chlorine valence electrons are 7 and that you have to draw to its side. If it will lose one electron, if sodium will lose one electron, it will be acquiring its nearest noble gas configuration. So complete transfer of electron takes place from sodium to chlorine, and sodium gains positive charge because it has lost the electron and it got +1. Chlorine has gained that electron, so -1. This force of attraction, okay, so the force of attraction that is there between these atoms, the ions that are formed, is known as electrostatic force of attraction. Now in this case, what has happened, that sodium was neutral, it has lost its electron and formed Na positive. So this is a cation which is formed. For example, we have taken for sodium, atom changing to sodium ion. So positively charged ions are known as cation, don't forget this. And the next one, chlorine, that is an anion. The other example that we are going to take is magnesium chloride. First of all, its atomic numbers and then its electronic configuration. Now magnesium need to acquire its nearest noble gas configuration. It need to give this 2 electrons. But chlorine, one chlorine can take only 1 electron. So therefore, for the formation of magnesium chloride, 1 magnesium and 2 chlorine are required. So magnesium with its outermost shell electron we have to write, chlorine with its outermost shell. So 1 electron it gives to 1 chlorine, and the second electron of magnesium is given to second chlorine. Magnesium has lost its 2 electrons, so it becomes +2 charge, and chlorine has gained 1 electron, so -1 on both sides. The force of attraction that resides between these ions is electrostatic force of attraction. That also you have to show with an arrow. The third example of electron dot diagram is of calcium oxide. The formula of calcium oxide is CaO. Calcium atomic number is 20, oxygen's atomic number is 8. So it is 2,8,8,2. If it loses this 2 electron, outermost shell will be having 8 electrons. So therefore, calcium loses 2 electrons. Similarly, if oxygen is having 6 electrons in its outermost shell, it requires 2 electrons to complete its octet. So it gained that 2 electron. So you Ca +2 forms and oxygen gets -2, and the force of attraction is electrostatic. Now this was all about electron dot diagrams. Now next we are going to discuss is orbital diagram. It's very simple. Only what happened in the electron dot diagram case, we have considered only valence electrons. But in the orbital diagram case, we'll be considering all the shells in an atom that are there. So its electronic configuration of sodium is 281. We'll draw all the 3 shells with a nucleus in the center, and will be showing a transfer to chlorine. And after transfer, since only 1 electron was present in that shell, that electron has gone, so no need to draw that shell also. So 2 shells will be drawing in sodium ion and 3 shells that are complete, that you'll show in chloride ion. And there is a force of attraction that is residing between the two, that is electrostatic force of attraction. They can give you a different one also. They can tell you to draw electron dot diagram, or they can tell you to draw orbital diagram of magnesium chloride. then in that case also it's simple, it's same. Only thing is that you have to draw all the orbits that are present. You will show the transfer and then the electrostatic force of attraction, what charges that they are having after the transfer of electron has taken place. So in this particular lecture you have studied that how is electron dot diagrams drawn, how is orbital diagrams drawn of the ionic compounds, what are ionic compounds, how is it formed, then conditions for the ionic compounds. So students, this was all for today. In our next lecture we are going to discuss another topic from the same chapter. Thank you so much.